Let's now talk about a particularly space-efficient type of warehouse construction, the silo or Clad rack warehouse. You'll also hear it referred to as a rack-supported warehouse. In most warehouses, the building is constructed first, a steel framework, walls, roof, the whole envelope. Then the storage systems are brought in and installed inside. But in a silo warehouse, this sequence is reversed. The racking system is built first, and then the building, walls, and roof is mounted directly onto the rack structure. In other words, the racking is not just for storage. It becomes the primary load-bearing structure of the entire building. This design has some fascinating implications. First, you're saving a huge amount of structural steel and construction effort because you no longer need separate structural supports for the building and the storage system. The racking takes over both roles, holding up the pallets inside and holding up the roof and walls. That's why the term clad rack is used. The racking is clad in walls. Let's look at the image on the right. This is a real-world photo of a large-scale high-bay silo warehouse under construction. The steel framework you see here is not for a conventional building. It is the rack itself. One of the biggest advantages of this construction method is height. These systems can reach well above 30 meters, in some cases even up to 45 meters, because there's no architectural limitation from a separate building envelope. And since the racking is continuous from the ground to the top, the entire system is optimized for vertical capacity. Now you might wonder, what kind of storage processes are used in such buildings? Well, due to the extreme height, manual operation is practically impossible. Silo warehouses are almost always fully automated, meaning they are equipped with storage and retrieval machines that move goods in and out of the racking. So why build a silo warehouse instead of a conventional one? We mentioned one reason, height, already, but there's more to it. Let's begin with depreciation. This is a financial argument that's often overlooked in technical discussions. In traditional warehouses, the building itself is treated as real estate. And real estate typically has a depreciation period of 25 to 33 years, depending on local accounting rules. But in a silo design, the racking structure, which is the building, is considered equipment, not real estate. And equipment usually depreciates faster, often within 10 to 15 years. That means you can write off the investment faster, which can be very attractive from a corporate finance perspective. Next is implementation time. A silo warehouse can be built much faster than a conventional warehouse. Why? Because there's less heavy civil engineering involved. The racking itself is anchored into the ground, and you build upward from there. This can shave months off the project timeline. Now let's talk about cost, probably the most compelling argument. Building tall warehouses using conventional steel construction becomes very expensive beyond a certain height. That's because traditional buildings require increasingly robust structural members as the height increases, and you still have to install racking inside. By contrast, silo systems scale more efficiently. A good rule of thumb is this. For warehouses over 20 meters in height, a silo design is almost always cheaper. That threshold, 20 meters, is often used as a break-even point in feasibility studies. So to answer the question, why would you build a silo? To optimize space and vertical capacity, to reduce structural costs for high buildings, to speed up implementation, and to benefit from faster depreciation and better cash flow dynamics. That said, a silo warehouse isn't always the best fit. For instance, if you expect frequent layout changes or if your processes are too complex for automation, then a traditional building may offer more flexibility. But if you need large-scale storage, a fixed layout, and a high degree of automation, then silo construction is often the superior choice.